Oh, good morning. Welcome to this session on Kotlin. Are you all good? But just very quiet? Extremely quiet? First time ever in my life in 20 years presenting in Vienna. So I've got to figure out what kind of crowd that you are. Are you the quiet crowd like the Swedish? Are you more like the Finnish that feel like they're dead at times? Or are you more like the Spanish or the, yeah, so trying to get a feel for it. Don't help me out though, just stay quiet. Okay, anyway, welcome to this talk on Kotlin, ready for production. My name is Hadi, I work at JetBrains. I'm somewhat involved in Kotlin in a sense. How many of you here know Kotlin? Have played with it? Are going to play with it after this talk? Hopefully everyone. Those that won't, at least you'll end up with a Kotlin sticker if you want. So, yeah. You will walk away with something from this talk, I promise you, even if it is hate for me. Okay, so background, a little bit, because, you know, like every time you talk about a new language, people are like, why a new language? Imagine if they had asked that about JavaScript. We would have been all better off. Started in 2010 by JetBrains. We needed a language. Why? Because we had NIH syndrome. No, I'm joking. Because everything else out there didn't kind of suit what we needed. So the main candidates at the time were Scala and Ceylon. In fact, we started using Ceylon proactively. At some points, our interests and the Ceylon's team's interests diverged, and that's when we decided to just bite the bullet and write our own language. Why did we need a language? We needed a language for our own tools. By and large, the majority of the tools that we write at JetBrains, like 50% or 70% of them, are on the JVM platform. And we basically, you know, we've got IDEs for everything you can think of, except Frege. And by and large, they're still all written in Java. So we wanted a language that allowed us to be a little bit more concise, which isn't hard compared to Java. Expressive, toolable, interoperable, pragmatic. And pragmatic is the key word there. So that's why it came about. It was developed under Apache 2 OSS on GitHub from pretty much day one, and it's still there 5 years later, or 6 years. What is the current state? 1.0 was released on the 15th of February. Those that thought Kotlin will never release, well, we proved you wrong. We did, 6 years later. Minor little note. 20 plus developers at JetBrains. So proactively, there are 20 plus team on the team right now. There are 20 plus people on the team right now working on Kotlin. 100 committers plus on GitHub, on the project itself. Obviously, not everyone from JetBrains. And it's used in close to 10 products at JetBrains. So Kotlin isn't a business model for us. We're not trying to create a consultancy around Kotlin or an ecosystem around Kotlin, because one of the things that we really wanted with Kotlin was for it to be interoperable with everything that already exists out there. So we're using it for our own need. Obviously, the more people use it, the better for us. Fantastic. But we're like dog fooding it, and we're knee deep into this project. Since January 2016, there's about 14,000 plus users, active users of Kotlin. That's not downloads. That's kind of like active users that are using it. And that's only in our environment, because Kotlin is free, open source. You can use it in the IntelliJ Community Edition. You can use it in IntelliJ Ultimate. You can use it from the command line, from Ant, Gradle, Maven, anything you want. We even have a Eclipse plugin that we've been working on and we've released. So 14,000 plus people there, and external companies. I just found out American Express is also using it for some projects that they have on GitHub. So those are a bunch of, I'm name dropping here, right? And then I'm the same person that says, don't use X just because Y uses it. So apply that thing there as well. But hey, it looks good on a slide. Where can I use it? Anywhere. Given that it's compatible with Java 6 and it's got a small runtime, it's seen like an explosion on Android. But this is not an Android-specific language. We didn't design it and say, let's go after the Android market. We created a language for us, an industrial language that could be used for anything, whether it's web frameworks, whether it's server-side, whether it's anything you want. But as I said, because it's compatible with Java 6 and because it's got a small runtime, People like it on Android because it brings lambdas to an otherwise non-existing lambda environment. It's very similar to Java, C#, and JavaScript, which basically means that you can ramp up very, very easily. So if you're familiar with any of those languages, in a day, you're going to understand Kotlin. It'll take you 2 days, 3 days, 5 days to get some idiomatic senses of how to better use Kotlin, but pretty much you can understand Kotlin from day one. And that was one of our objectives. We didn't want a massive mind shift from developers of saying, you know, creating an esoteric language that is completely disconnected from what we're used to currently. If we wanted something like that, there's many things to choose from. Some people like, you know, if you are like, for instance, a closure programmer, this isn't a radical mind shift. It has some functional aspects of it, but by and large, you will understand this. And interoperability is one of our strong points and one of our points that we continuously focus on. We want everything that we do to be interoperable with the existing ecosystem. So when you come to Kotlin, you don't say, oh, what web framework can I use? What testing framework can I use? What build system can I use? You can use anything you're using on the JVM. That's the whole goal of it, so that you can integrate with existing products, existing libraries, etc. So interoperability is very, very important for us. Another aspect is, can I, for example, take an existing library on the JVM and add a thin wrapper of Kotlin around it to make it more idiomatic or more concise or a better API for it? Absolutely. And that's what a lot of people are doing. But under the covers, everything else is just pure Java JVM jars. How can you use it? As I said, command line, Maven, Gradle, Cobalt. Cobalt is a system that Cedric is working on, the guy behind TestNG, and it's basically inspired by Gradle but strongly typed, because Kotlin, which I forget to mention, is a statically typed language. So Cobalt is kind of like a statically typed Gradle kind of thing. And IntelliJ IDEA, Android Studio, Eclipse. Is there anything that I have not mentioned that anybody in this room uses? NetBeans. I'm sorry. NetBeans, currently you have to use the command line. There's no support for NetBeans. But as I said, it's open source, so pull request, welcome. Okay, so rest of the talk is going to be basically me showing you Kotlin. Do you have any questions before I do that? Fantastic. So I'm the session right before lunch. And I hate that because they always do it to me. And everyone's like, shut up already, I want to go eat. So new project, this is what you get, a new logo. You also get, so Kotlin basically, it can use the IntelliJ build system, it can use Gradle, it can use Maven, etc. So if I click on Gradle, I can select that I also want Kotlin as part of the Gradle package. I can just click Kotlin here. You can see that also we have targeted JavaScript in addition to JVM. It actually works. Why did we do it? To try and attract the hipsters, because hipsters love JavaScript. It works. It's great. We're going to focus more on it after 1.0. So now we're actually proactively focusing on the JavaScript backend. It is fantastic for scenarios where you can share code, for instance, right? I have some business logic. I'm doing some stuff on the JavaScript side. I'm doing something on the server side. I can write my code in Kotlin once, ship it to 2 places, and then do some business validation, etc. So we're going to improve the experience moving forward after this 1.0 release that we just had. Up to 1.0, a lot of the concentration was put on the JVM as well itself. So I can give it a name. Let's do this in a more like a Java way. Instead of calling it a name, I'll call it a name factory bean. Then you can use the library, so you just click create here, and then it gives you 2 options. Kotlin comes with a small runtime, so you can say, do I want to ship it as part of my project, or do I want to use the, well, not ship it, kind of like reference it directly, copy it to my project, or do I want to use the one that's provided by the environment in the plugin? Usually you do use library plugin. Of course, as you update the plugin, so will your project. If you want to keep it the same, then use copy to. Having said that, most of my projects are basically with Gradle, so I hardly ever use this. There we go. And now I have my source folder, so I can say Kotlin, bada bing, get some. This is the public static void main in Kotlin. We'll get into this. Top level functions, which we'll also get into. And then we'll just like print line, hello from Voxxed Vienna. Great thing about this is that every time I go to a different conference, I do a new version of this. And then hit run, and that compiles, and it spits the output. Okay? And of course, I can also set a breakpoint and debug that. So very, very easy to get ramped up and get stuff going and running with it. Now, having said that, let's switch over and look at some code. What's this? Somebody tell me. I'll give you a hint. It's at the very top, next to where it says public class. What is it? It's a Java bean. This is why we invented IntelliJ, so that you didn't have to write this manually. Right? How many of you write this code? How many of you get IntelliJ or your IDE to write it for you? Yeah, there you go. So this code, let me just do this in a very hipsterish way, which is open split. Now let me show you the equivalent in Kotlin. So there's the Kotlin equivalent. Okay? Now this is nothing earth-shattering, nothing amazing. You're probably used to this in other languages, but that's the equivalent in Kotlin. Right? We're not making something amazing. We're just making it easier to write. We're just making it pragmatic. So what we've basically done is cut down all of that code to a single line of code. I hate saying that because it really sounds like Microsoft when they're like, next version you won't even have to write a single line of code to write this full-blown ERP application. We call it Silverlight. Anyway, so what this is basically is creating for me a class. Actually, this is creating the class. And in fact, you can see that I have no body. Bodies are optional in Kotlin. What I have is just a class with 4 properties. There's no fields in Kotlin. I have properties. And these properties have either var or val. And var means mutable, val means immutable. By default, Kotlin doesn't enforce anything, but we recommend, like many people, to use immutable objects. So I've created a class which has a read-write property, etc. Now what I can also do is add this annotation, which is data, and what that does is provide me with equals to string and hash code, right? So basically by just adding a single element, a single keyword, single annotation, I get all of the functionality that you can see here. And the purpose of this is none other than just to save code. Just to have to not maintain so much code. Because even if you never touch this code, psychologically it hurts. Because when you open a file and you see so much code, you actually have to see if there's anything custom, right? You don't know if there's anything custom or is this just the auto-generated code. You can, of course, put a little comment at the top, or you can use Kotlin. So now, one of the good things is that, like, I have this code here, and I can actually use this code from Kotlin as well, right? So if I have, for instance, let's switch back to this. Let me go ahead and create a class for you here, a Kotlin class, and we'll call it, for example, customer as well. So now what I did before, this thing over here, val abc string, that's pretty much the constructor. So in Kotlin we have primary constructors, which means that anything that I pass in already, I can set the value. You can have secondary constructors as well, which we'll see in a moment. And if I were to create a Java file here, for instance, Java some class, and then we'll do public static void main, and then I can now do customer equals new customer, right? And this is my customer, ABC. Customer, I get ABC, right? So I can mix and match my code, Kotlin, Java, Java, Kotlin. Much the same way, if I do a Java class, so say, let's go ahead and do Java customer in Java. And now this is where I have no idea how to write Java. String, name. What am I doing here? What am I doing? There you go. Now I go back to Kotlin and I do var c equals customer in Java. Notice that Kotlin doesn't have a new keyword, right? So new's gone. I could do get name, but you see what it's doing? Kotlin removes the get name set name. It just, you can reference it for what it is, which is a property. So I could just write name. Okay, and mix and match easily Kotlin and Java code, which makes it great because in principle what I can easily do is gradually introduce Kotlin into my code base. I don't have to radically change everything. I can start to add Kotlin beans, etc. into my code base. Okay, now let's take a look at functions. And let me close this. So, first of all, Kotlin has top-level functions, which means I no longer have to have a public static void, a static class, and then have a static method associated with that static class. I can just write functions anywhere, which is fantastic, because now you get rid of those horrible utility classes. How many of you got utility classes, right? Or helper classes. You can get rid of that. And instead of wondering where, in what method, your actual helper function is, because you got to locate the utility class, now you can spend time locating that file instead. Kind of like JavaScript, right? Just throw everything somewhere and then figure out where it is. But we do get rid of all of the boilerplate code of having the static class. So I have a top-level function here. I follow the syntax of Pascal/Delphi. So I have the parameter name and then colon and then the parameter type. Much the same way in the function return value. By default, functions return a unit, which is kind of the equivalent of void. If you don't want to, you don't have to write it. I have string interpolation or templating in Kotlin, as expected. I have default parameters. So I can just write param1, param2, string equals default. The good thing about this is, what does it do? Again, it gets rid of boilerplate code. I don't have to have overloaded versions just because of a default parameter. I have parameter naming as well, so I can pass in parameters based on the name. If you have a function with 12 parameters, refactor it and make it a data class. But if you really don't want to, you can actually pass in parameter name and change positioning. So here you can see that I'm passing in parameter 2 first and then parameter 1. If functions have no body, it's just an expression that it returns, then I can even omit the open and close braces. And also notice that Kotlin has very good type inference. So again, this is cutting down on boilerplate code. I don't need to be explicit and say this is returning an integer, because it can figure out that it's returning an integer. So here is just a single line expression function that just takes the value, multiplies it by 2. Functions can also have multiple arguments. So I can have var arg, which means I can have endless number of strings being passed into a function. Okay? So again, focusing on cutting down boilerplate code and doing some pragmatic stuff. What else do we do? We have, or we don't have, nulls. Here is typical Java code. If customer is not null, customer equals get first name. If it's not null, then if it starts with an A, throw security exception. This is some kind of some like logic that we have on some Spanish government websites. So the point here is that you can see yourself, you've suffered from this. Every single check has to be compared to null, right? In Kotlin, we don't have nulls. So by default, if I go to customer service in Kotlin, this can never be nullable. It can never have a null value, which means I don't have to check for nulls, which is fantastic, right? So that's all great. The problem, of course, is what happens when I want a nullable type, when, I want to do that. In Kotlin, we have the ability to create nullable types by just putting a question mark at the end. So now that means that the type is nullable. As soon as I do that, you can see that this goes red here saying, oops, that could potentially give you a null reference exception. And what we can do here is also add a little question mark and say, if it's not null, then invoke first name. Kind of like the optional thing that you have in Scala, Java 8, or Java 8. I think. Now, there's another issue here. If I'm writing new Kotlin code, I don't want to work with nulls, so I won't have nullable types. The problem is that, if we want to make this interoperable with Java, how do we interact with Java? And this has a long history. When we first started Kotlin, we said, okay, anything from Java that can return nullable, by default, is going to be like this in Kotlin, which means that every time you consume a Java method, for instance, that can potentially return null, you have to put the Elvis operator in front of it. That looked great to begin with, and then when we looked at code bases, everywhere there was question marks. So we said, okay, we'll try and solve that problem by creating an external annotation tool that annotates your code and then tells you you can remove the question mark because there is no need, because potentially this will never be null. That looked good, but then we got rid of that as well. So now basically what we've done is leave it to your discretion. If you know that a type from Java can potentially return null, it's your responsibility to do that. If you override a type in Java or implement an interface in Java, by default, for example, IntelliJ, if this were a Java class that I'm overriding validate customer, IntelliJ would insert that and say, you can potentially have null value. Now, if you're using JavaX annotations, or if you're using IntelliJ annotations, or any other kind of these annotation libraries that we support, and you know that that will never be null, you can actually come and delete that, and the compiler won't complain and say, fine, you're telling me this is not going to be null? Fine, I'm not going to force you to access it in that way. There's another operator that we have, which is a double hashbang, which is like that. And that is saying, I know that this can potentially be null, let me blow my foot off, right? So if you use this, you can potentially cause a null reference exception, because it's saying it can be null, but I will dereference it anyway. Okay. So as I said, if you're writing complete Kotlin code bases, by and large, you probably start to move away from nullable types. When you're interoperating with Java, there are scenarios where you have to work with nullable types, and we try and make it as concise and simple as possible. Something else we've added. So here's the thing. By default, Kotlin is final in terms of classes. So you have to explicitly call open, right? And what I'm doing here is I'm creating a class which is an employee which inherits from person. Person I can inherit from. I also have a contractor which inherits from person. What's the difference between a contractor and an employee? Contractors rip you off. No, I mean the contractors don't have vacation days. So validate vacations. I get in a person, I say if person is employee, person vacation days less than 20, you need to take more time off. Now, what is missing there? Anybody? A casting. And you can see, I don't know if you can actually see here. Yes, you can. You can see that this is green. It says smart cast. So Kotlin already says, okay, the compiler has checked that this is of type person. Therefore, I don't need to do that extra check. Sorry, I don't need to be explicit about it and say cast this to person and then get the vacation days. Sorry, cast it to employee and get the vacation days. Because the compiler already is smart enough to figure that out. So it's just that little bit of help that avoids you to have to write repetitively the same code over and over again. If I know it's an employee, let me just access it as an employee. Okay? So here you can see that I have vacation days. If I come here, well, not here, and say else if person is contractor, I can't do person vacation days. Okay? It doesn't offer it to me because it's not an employee. Talking about ifs. Ifs in Kotlin return an expression. So if as expression, result. If input is greater than 100, 30, else 20. The last line will always be the returned value of that expression. So then I could do things like var result. If input's greater than 100, then, do some operation and then return the value, else 100. And I could just assign that. I don't need to go with intermediate variables and then add the value based on the type, etc. One thing that we try and enforce in Kotlin, again, not enforce, but try and hint at, is the mutable types. And you can see that when I put var, it actually underlines it, kind of like telling you in your face, this is not the recommended way. Kind of don't make mutable values. You can one thing that I was saying, that you can put like fluorescent green on an orange background or something like that for your mutable types, and that way you will never write them ever. So delegation. Here's a typical pattern. I have an interface of type record, and initially in Kotlin we used to call interfaces traits, because similar to Scala traits where they could have default methods could have default implementations. Then Java 8 came about and said interfaces can do that, so we said let's just unite and all call everything interface. So here I have a record, and I have let's focus on this one for a minute. I have a repository pattern of generic type, restricted to record, get by ID, get all. And here I have a controller class. Now this is dependency injection, which we're all familiar with. The difference between this and what you're accustomed to is that you see that there's no private field here referencing that repository, is there? There's no repository that actually gets the value injected in. But there is this get all. So where is that get all coming from? That actually is a method of the repository. And what we do is we use this first class delegation in Kotlin, which is basically this syntax here. And what we're saying is the repository dependency that's being injected in, passed in the constructor, is delegated to repository. What that translates into is that it's kind of like get all, get by ID, all of those become mix-ins. They become part of my controller class. So I no longer have to prefix them constantly with repository.getById, repository.getByAll, etc. In fact, there is no repository because there is no repository field. There's nothing. So I can just reference them directly as if they were part of my class. Now the downside to that, of course, is that what happens is if I have 4 or 5 dependencies coming in, where does anything come from? There you can use IntelliJ. No, I'm joking. Where does it come from? The answer to that question is, why do you have 4 or 5 dependencies coming in to begin with? You really shouldn't, right? You really, really shouldn't. There's this belief that just because I'm passing in a dependency via a constructor, I'm creating loosely coupled code. And that's completely wrong, right? What you're doing is you're loosely coupling it to an implementation. What you should be doing probably is abstracting types to have higher level types that have less dependencies. Because if a class has 20 dependencies being passed in, it's more likely that it's controlling too many things or aware of too many things. Okay? So the general rule of thumb there is, if you have too many dependencies, look for a code smell somewhere else. If you don't have a code smell, then blame Kotlin. But you can, of course, also use the old pattern and say, no, I want to call this a repo, and then just reference it using a repo. Now, what we also do is delegate properties. So that's kind of like delegating functions. What this is doing is delegating properties. And here I have a customer class, And what I have is a list of addresses, and I have by lazy. Don't worry about this syntax right now. I'll tell you what that is in a moment. But I have this lazy thing. And what this lazy thing does is says delegate the functionality of this property to this function call. And this function call is over here, get addresses. Lazy is a built-in delegation that we already offer in Kotlin. And what it means is lazy evaluation. That means lazy initialization. When they access this property, only initialize it on the first access. You can use built-in delegations that we have, or you can create your own. I'll get to the syntax in a moment. Don't worry about it. With classes, as I said, we've seen this syntax all the time, which is the primary constructor. There is the init block, which basically is what I want to initialize in a class. So I have the ability to initialize anything. Most of the time, if I'm just creating DTOs, I have none of this. If I have some initialization code that I can't do as part of a default parameter, etc., I can put it in an init block. If I want secondary constructors, I can add them as constructor, and they all have to call the base one. Now, initially, again, we didn't have we first had secondary constructors, then we got rid of secondary constructors and said to everybody, you can by and large just use default parameters. However, there were certain scenarios where default parameters weren't looking too good, and we reintroduced the concept of secondary constructors. Okay, so those exist. Deconstructing is about basically giving me insight into semantics and meaning, expressiveness to the code. Here I have a typical for loop where I say for element in elements, again, conciseness, no explicit type declarations, etc. And element is a pair. So that's another thing in Kotlin that we have, pair and tripe, triples or tripes, triples, whatever. Initially, again, we had tuples, then we got rid of them because we thought that after X amount of values, they start to lose semantics and data classes should be sufficient. So you have pairs and triples. Beyond that, you use a data class. So here I'm passing in pair, string, string. I don't know exactly what that is. I can reference them as first and last or second, but it's meh. It's like not telling me what this is. So what we do is you can deconstruct these into two variables with actual meaning. So I can say for city, comma, country in elements. Now I can refer to them for what they are. Much the same way I can do the same when I have a function that returns a pair. I could deconstruct it into two variables with two different names and then use them in that sense. Okay? Again, in terms of conciseness and expressiveness, this is how you implement a singleton pattern in Kotlin. We have the concept of objects. So if you're familiar with JavaScript, they have headaches. They also have not real classes. They have objects, and then when someone goes from Java to JavaScript or C# to JavaScript, tries to re-implement the whole class hierarchy. But you don't have classes as such in JavaScript. In Kotlin, we have classes that you've seen, but we also have objects. And objects is just basically a single object that I can initialize and then reference anywhere. So here I'm referencing the object Jeremy that has a version that has functions. So if you want to create a singleton in Kotlin, pretty much just declare it as an object. Objects you can also use to implement specific interfaces, abstract types, etc. But that's just an object declaration, and just reference it and use it wherever you want. Now let's get to the really cool stuff, which is higher order functions and functional programming. Because you know what they say nowadays. It's if your language doesn't provide functional constructs, you're doomed. And if you haven't heard, functional programming is this awesome new paradigm that's just come out. I saw a tweet from a JavaScript person saying that functional programming is this brand new paradigm that's recently come out, as opposed to 70, 80 years ago. Anyway, so here's a higher order function in Kotlin. A higher order function, if you're not familiar with the term, is a function that takes a function or a function that returns a function. And here is a function that takes two integers and returns an integer. So I can pass in a function and then call that function. Here is a function that I can pass in. here is referencing that function by name. So I use a similar syntax to Java. I just say colon, colon, my sum. Except with Java, you prefix it with the class. So I can reference functions by name. Here is the function using a lambda expression, anonymous function. So I'm just saying pass in the lambda, xy equals x plus y. Compare this to Java and you'll see that it's slightly more concise. In fact, there's a very good blog post on Stack Overflow by a guy very active in the community called Jason Minyard, where he compares all of the calls around collections working with Java with Kotlin, and see it yourself what the difference is in terms of conciseness and expressiveness. Now we have in Kotlin something similar to Groovy in that if the last parameter of a function is another function, I can omit the brackets, which means that this and this is exactly the same. And what's nicer is that this is exactly the same as this, right? And this is one of the good things about Kotlin. It starts to provide you with the ability to create these beautiful DSLs, because I'm just passing in a function to another function. So I could do things like using statements or try with resources. Basically, all it is a function as another function. However, the way it looks now is what? It looks kind of like a keyword. Imagine if you were to do something like a lock here, that locks an object, accesses it in a thread-safe way, and then releases it. Kotlin also comes with a whole standard library of many functions, such as filter, sorted, map, flat map, all of the things that you would come to expect. So here, for example, I have two data classes. I have a list of albums. Again, this is part of the standard function, standard library, which creates a list of elements. Very, very concise in how we express it. No type inference. I mean, a lot of type inference, no explicit typing. And what I have here is, for instance, filter numbers that are even. Here I have take the list of words over here and sort them. Here what I'm doing is mapping a list of a pair of country, city, country, and getting the city and then sorting it. This 2 is the same as me doing this. Pair, Vienna, Austria. Sorry. This is exactly the same. 2 is a built-in function that we provide to try and make it a little bit more expressive. It's just a function that returns a pair. Okay? So I can do 2 sorted. Here I can use flat map, and then inside flat map call filter, and then do all of the beautiful functional stuff that you all love and are used to. Now, taking this higher order function stuff, what we can do is some of the things I was mentioning. Here, for instance, I have let. And what let does is allow me to, as it says here, call the specified function block with this value as its argument and returns its result. So effectively what it means is that I can now reference the file here with a it. It, again, is a convention similar to Groovy in that when a lambda has a single value, I don't need to explicitly name it. I can just reference it with it. With does something similar. With takes the actual object that you're using and then invokes it without having to continuously prefix it with the variable name that you've assigned. And apply applies a function to that actual object. Now the next step with functions is extension functions. How many of you are familiar with C#? So C# has this concept of extension functions, which basically means I can take a class and extend it with new functionality without having to inherit it. And what you do in C#, you create a static class with a static method, and then you have a parameter that you have to pass in, which is called this, and it's kind of boilerplate. This is how you create an extension function in Kotlin. You just put the class name, dot, and the function you want to create, or extension properties. So what I've just done is extend the string class with a function called hello. And I can extend Java classes or I can extend Kotlin classes. Here I've extended the string class with a function called welcome, which allows me to now also reference the actual instance using the keyword this. I can also pass parameters to extension functions. So here you can see me using all of these extension functions. What is the scope? It's as long as the package is imported, that extension function exists. If you're using, of course, IntelliJ, for instance, you type it, completion provides it for you and says, auto import this extension function. Now, what we can also do is pass in extension functions as higher order functions. And this is where it gets interesting. Because here I have three classes: class root handler, class response, class request. We've all seen up to now. Now I have a root, which is path and handler. And handler is passing in not a higher order function, but an extension function. So it's anything that's an extension to root handler can be passed in. What is the benefit of doing something like this? When I use root or route, now what I have is access to all of the properties of the class. So you can see that here I have request. Where does request come from? It comes from a property of the root handler. Okay? And this is what allows us to do things like, if we open up Chrome and let's do Kotlin HTML builders. If you're familiar with the type-safe Groovy builders, this is basically the same concept. It's using a combination of extension functions, the convention that I can call functions dropping the brackets if it's a function, and extension functions as parameters, as higher order functions, to be able to create a statically typed HTML builder, right? So if you're familiar with the Groovy HTML builders, this is basically the same thing except it's statically typed. Now, given I personally wouldn't use an HTML builder that's statically typed, but this does give you an idea of what exactly you can do with these few conventions that we've built into the language and functionality that we've built in. Talking about functional stuff, if you're familiar with Haskell, for instance, or function composition, Kotlin doesn't come with function a compose operator or anything included, but this is how you could make a compose. So what this does is compose one function with another. And since it's top level, since I can just call it, I can just basically call it from anywhere. I don't need the boilerplate of having to have a class or instantiate a class, etc. There's a very good library which is called Functionally with a K, which is by Mario Arias, open source on GitHub, and he's added a whole bunch of new functions that aren't part of the standard library, such as compose, partial function applications, currying, optional types, etc. to Kotlin, which if you want to use that stuff, you can also reference or write it yourself. By default, Kotlin also has all the collections are eager load, are eager. There's no lazy processing, but we have a method which is called the function, which is called asSequence, which basically does lazy loading over all types of collections. Kotlin didn't reinvent our own collections. We're completely interoperable with all of Java's collections. Okay, we have some interfaces on top for mutability and immutability. And one last thing, if you're familiar with this concept, or if you're familiar with the algebraic data types, is does Kotlin support algebraic data types? In this sense, it does. So here I have a class which is page result, and inside it there's another class which is success, and it inherits page result. I then have another class which is error that inherits page result, and I mark this with a keyword sealed, which means that's basically it. There's not going to be another type of inherited class from page result. What this then allows me to do is practical things. So here I have a calling page function. How many times have you created a function that returns a value or returns an error? Many times. And if the error is returned, often is different to the actual value you would want. So you create a data class that says is error, and then if it's is error, read some value, etc., or throw an exception. Here I can say I have a function called getPage, and what getPage does is if the result is success, then print line URL. If the result is error, result print line message. This result is automatically being casted to the specific type that is returning in each case. So I can have, based on success or failure, different types being returned from the function. So here, get page result, you can see that if the operation is successful, I create a page result success. If it's an error, I create a page result error. Very useful to use in this sense. So initially we actually had a warning hint that was raised that was this is a non-exhaustive case switch statement. Right now, if you were to add, let's go ahead and, for example, add another one. Class, bada bing, I love, page result, right? You see that it's still going to compile and it's not going to give you any error, right? Before, as I said, we did have a hint that said, you know, there is potentially a flaw here in what you're trying to return. But we removed it because apparently it was kind of confusing. So you can also, of course, access this from inside Java. This is just a regular class that you can interoperate with and access in front of Java. Okay, so let me switch back to Keynote a second. Here are a few more examples of things you can do. Anko, how many of you doing our Android development? So Anko basically allows you to use some of the stuff that I've shown you. It's by us, it's open source, it allows you to create statically typed layouts instead of using XML. Android extensions, this is basically when you're doing Android, you spend up a lot of time doing find by view rd text view as text view to get the actual element on the Android. Now what we do is we use because the compiler has plugin technology whereby we basically parse during development time your XML and give you statically typed controls. So now I could just do text view set text, and text view is the name of the control I have. That's called the Android extensions, which is available for IntelliJ and Android Studio. Spring Boot, they've already added support for Kotlin because Sebastian is a big fan of Kotlin. So now you can create applications with Spring Boot. And again, this isn't only about Android. So in fact, JetBrains account, JetProfile, a bunch of applications that we have at JetBrains, some of them are public, like JetBrains account, are all web applications. JetBrains Pro account isn't on Spring Boot, but you can nonetheless use Spring Boot to create applications as well. Cobalt, as I said, is a build tool by Cedric, which is basically following, very heavily inspired by Gradle. Spec, that's a little thing that I wrote when I first was experimenting with Kotlin, which is kind of like, if you're familiar with Jasmine from JavaScript, it's kind of the same thing. Specification framework, if you will, or unit testing framework, however you want to call it, or just don't call it a BDD framework. Okay, and next steps, what can you do? Kotlinlang.org, if you want to find out more. Try.kotlinlang.org is really good. We've got a whole bunch of koans that you can go on there in an IDE, online IDE, and start playing with Kotlin. You don't have to actually install Kotlin or anything like that. There's a whole bunch of koans that you can complete. There's 5 levels, and it gives you a good idea of the syntax of the language itself. If you want to do it offline, you can, of course, go to the Kotlin koans on our GitHub repo, clone it, and do those online or offline with any of your favorite IDEs. Books, there's already a couple available. This one's still getting ready by my colleagues Dmitry Yemerov and Svetlana Isakova. So this is going to be a Kotlin book basically covering the entire language. This one is Kotlin for Android developers, already available by Antonio Leiva, and it's on LeanPub. It's like 160 pages focused around Kotlin and Android development at the same time. Community, that's outdated. We've already got over 2,000 people on our Kotlin Slack. So if you are going to pick up Kotlin, join the Slack. It's very, very, very active, like over the top active now that we can't even follow conversations. And of course on Twitter, there is Kotlin if you want to follow up for news and events, etc. So to summarize, hopefully you'll understand what I meant by pragmatic. We're just trying to find pain points that we've suffered, others have suffered, and try and address them in a concise, clean way. Easy learning curve, because if you're familiar with the languages that I mentioned, it won't be hard for you to pick up. And interoperability provides that low-risk adoption. I don't need to throw out the baby with the bathwater to adopt Kotlin. I can gradually bring it into my code base. And as I see value, I increase the number of classes, code that I write with Kotlin. There we have a functionality in IntelliJ which you can select the Java class and say convert to Kotlin. And it converts it to Kotlin. It's very good to get up and running and understanding the syntax. And of course it's enjoyable. And of course this is very, very, very subjective. But I personally love it. And one of the things that always kept me away from the JVM was Java, unfortunately. And coming from C#, now when I go back to C#, I find that even a little bit boilerplatey. So concise. For me personally, it brings a lot of the stuff that I love about JavaScript, except static typed. But don't go down TypeScript. Don't even ask me about TypeScript. Don't. That's just a whole, no, never mind. And as I said, we heavily invested in this. We using it in our products, up to nearly 10 and some products. The Rider, which is our new C# IDE we've recently announced, front end completely written in Kotlin, some other products. So we're invested in it. Kotlin is here to stay. It's not going to go anywhere. And this is a tweet that I asked for permission because it's like, it was quite nice. It says, I researched Kotlin last night and then spending the morning looking at mountains of boilerplate Java and Android Studio. I see why they did it. Yep, that's pretty much it. That's why we did it. Thank you. And I have some stickers here if you want some Kotlin stickers. If not, just come to me later. If you're too embarrassed to come now, it's fine. You can go and have lunch.